We are continuing on with the vertex form of quadratic functions. So now I'm going to see how we can use this to fairly quickly graph it instead of just plotting a whole bunch of points. So here I see that this is in vertex form. I can tell what the where the vertex is. This means it went left 1, right? So I have -1 and up 5. So I have a vertex at -1, 5. I'm going to go ahead and plot that point. -1, 1, 2, 3, 4, and 5. The other thing I know in plotting this is that this is my axis of symmetry at x equals -1. That means all the points over here are going to be the same as over here once I start plotting them. The other thing I know, because this is a -2, it is going to be opening down, and that'll be apparent when I start to graph it, but it's just good to know. I'm going to put in a point over here. What I like to do is pick a point, put in 0 to start out with, and let's see what happens. If I put in 0, I have 0 plus 1 is 1. When I square it, I still have 1. I multiply it by a -2, which gives me a -2, and then add that to 5. So I have 3. So I have the point 0, 3. 1, 2, 3. As soon as I plot this point, since this is the axis of symmetry, I count 1 to the axis, and then I count 1 over here, and I'm able to plot that point. And then it's a good idea to pick another one so that I can just have another reference. If I put in 1, I have 1 plus 1 is 2. 2 squared is 4. 4 times -2 is -8. Plus 5 is -3. So I'm going to graph the point 1, -3. And now, since this is symmetrical, I'm going to count 1, 2 to the axis of symmetry, 1, 2 right here, and I can graph that point, and then I have graphed my graph. So once you can remember, find your vertex, you can do it fairly quickly. I was just looking to see if there's another example I can do. Let's go ahead and say f of x is equal to -3. So I know it's automatically going to be opening down. X minus 2, quantity squared, plus 1. When I'm looking here at my vertex is going to be 2, 1. That means it moved 2 to the right and up 1. I'm going to go ahead and graph that point. 1, 2, up 1. This also means that my axis of symmetry, if I want to lightly draw it in there, is at the point x, or at the line x equals 2. If I want to, and I said before it's going to open down. I'm going to go ahead and put in 0 here, and I will get a -2. When I square it, I get 4, because -2 squared is 4. 4 times -3 is -12, plus 1 is -11. If that gets to be, hang on, I can't talk and count at the same time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If the math gets too difficult, you can write it out. I'm just doing mental math on it. I'm going to count over 2 and count over 2. I could also put in 1 here to see what happens in between here. If I'm not going to go any bigger than, or any smaller this way or bigger this way, because it won't fit on my graph. If I put in 1, I get -1. Squared is 1. Negative times -3 is -3. Plus 1 is -2. So I have 1, -2, which is going to give me, I graphed them wrong. 1, -2, and then what is this? 1, 2, 3, -2. And so I'm going to, and that's how you graph it, just like that. Okay? There's one more example that I will do. And you can see how quickly it is, how quickly you can graph when you are using this format, instead of just picking a whole bunch of values and then having to plot points. Again, looking at my vertex, it's going to be -1, 4. I'd move left 1, down 4. Oops, -4, I'm sorry. -4. So I'm going to, over here, graph the point -1, -4, 1, 2, 3, 4. This is my axis of symmetry at x equals -1. If I put in a point 0 for x, I have 0 plus 1 is 1. 1 squared is 1. Minus 4 is -3. What was that? I forgot what I put in. 0. -3. And that makes this one work too. I count 1. I count 1 over. Both of these, whenever there's a point on one half of the parabola, it's the same distance away from the x-axis, and that's why that is so helpful. Let's go ahead and put in 1 for x. When I put in 1, I get 2. 2 to the second power is 4. Minus 4 is 0. So at the point, it's going to cross the x-axis at the point 1, 0. And I count 1, 2. I count 1, 2. There's my other point. Again, there's a 1 here. This just means it's not any wider or skinnier than the parent function, and I can graph it in. It's opening up because that is positive. So that's how you quickly can graph using the vertex form. Okay, this is the word problem, example 5 on page 325. You are going to love this one. Two people are playing soccer when Deshaun or Chris kicks the ball, I guess. Kicking it, this is where her foot is at the point 2, 1.2. And because she's standing over here, so by the time she hits the ball, it's 2 feet away. It comes up like this. This is the vertex right here that they're giving us at 1611. That means it's 16 feet away from where she's standing and 11 feet high in the air. And then at this point, it's the turning point where it's going to start coming down. The net is 25 feet away from where she is standing. And the goalie is standing 3 feet in front of the net and has a span of, he can reach 8 feet high when his arms are up in the air. So that puts him at the point 22.8 where his hands are right here. So what we want to know is when we plug all this information into an equation, is this point right here, will it work in the equation? If it does, then yes, he'll be able to stop the ball. If it doesn't, then no, he won't be able to. Okay, that's what it boils down to. So we're starting with this, the equation in vertex form. We're going to go ahead and substitute in the vertex right here. So we would have f of x is equal to a times x minus 16 quantity squared plus 11. All I did was take that vertex and put it into the vertex form. The problem that we have now is we have too many variables going on. We're trying, so we have to find out what a is. In order to do that, we're going to take a point that we do know. We do know this point right here, because this point definitely will work in the equation. We know that because we can see it's part of the graph. When we put that in, we are going to get f of x, which we know is 1.2, that's the y value, is equal to a, which is what we're trying to find out, and x is 2 minus 16 quantity squared plus 11. I'm going to have to probably go get a calculator in order to finish this. So I have 1.2 is equal to a times negative 14 quantity squared plus 11. When I square negative 14, I have 196a plus 11 is equal to 1.2. I'm going to subtract 11 from both sides. So 196a is equal to, I'm going to go ahead and peek, negative 9.8, since you're not here to help me do the math. And then I'm going to divide both sides by 196. So a is equal to negative 0.05. So that's what this number is right up here. I am now going to rewrite this equation that I'm using and put in the negative 0.05 in that spot. So I have f of x is equal to negative 0.05 times x minus 16 quantity squared plus 11. Whoops, I keep writing off the edge of the paper. Plus 11. Okay, when I go back to the problem, this is where the goalie is standing, and he's 3 feet in front of the net, so he's standing at where x is 22. So we're going to go ahead and put in 22 for x. So f of x, or we could call it y, is negative 0.05 times 22 minus 16 quantity squared plus 11. I just substituted in that x value. What I want this y to be, the output, I need it to be 8, because that's where his hands are, is at 8. But I'm going to actually solve it and see what it is, and that will tell me if it works or not. So I'm going to go ahead and switch this to y, because I know it's easier for you to understand. But I'm going to have negative 0.05. 22 minus 16 is 6. 17. Yep, 6. When I square it, I have negative 0.05 times 36 plus 11. I don't have a calculator, so I am going to... Oh, they didn't shorten it. They just did it. When you do all of this math, when I multiply this and add it to 11, y comes out to be 9.2. We needed it to be 8. So what that means, he will not be able to stop the ball, because here's 8 and the ball is going to be up here at 9.2, so it's going to come like this, and it's going to go right over his head. He would have to jump another 1.2 feet in order to catch it. So that's why he cannot block it. So I know that's a lot. You can look over in the book. You can ask me on Thursday, but that's how that works. So it says if Deshaun does not block Chris's shot, will it be a goal? And so if you want to go ahead and try that, the next thing you're going to do is, in order for it to be in the goal, it would have to hit the ground someplace in here without hitting the net up here. So that's something that you can go ahead and try. I'm not going to do it. I'm not going to do it right now. So I'm going to go ahead and upload. I'm going to do worksheets in case you're interested, just to make it a little bit easier. And I will go ahead and post the answers with that, in case, so that you have the answers to work with. If you have any questions, you may email me.